Assalamualaikum. Alright, in this video we are going to discuss about the implicit differentiation, where the concepts of all the techniques of differentiation, the derivatives of trigonometric functions, the derivative of the logarithmic and also exponential functions will be used a lot in this video. Alright, so for this topic, so before I go to the actual content of the topic, so let's just define what implicit is. All right, so from the Google, if you Google, the implicit means it is something which is not directly expressed, or you have something which always have to be found in, right? And like for example, what's mean not direct here? So alright, some other keywords which is indirect here. So like for example, if you have y equal to 3x, so the differentiation is very direct, so dy over dx is equal to 3. Alright, but for the case 2, which is the concept of implicit differentiation, so it is not direct. So let's see what is meant by not direct here. Alright, so we have ln y will be differentiated as 1 over y dy over dx. All right, and then you have x will be differentiated as 1, and then you have sine y will become cos y, and then you have dy over dx. So this is not direct because we don't directly from this, we don't directly get the dy over dx. All right, what is dy over dx here? So you have to collect all this dy over dx from the terms, and then only you can get the expression of the dy over dx. So this is what it means by implicit differentiation, meaning to say that you have to do a lot of calculations or workings before you get the final answer for dy over dx. All right, so let's look at question number 1 here. So if we have this type of functions, all right, so what we do first, all right, I would like to say, all right, so let's say this is a, okay, this is a, and then I put this is B, and then I take this is C, and this is D. All right, so I'm gonna write A prime will be, all right, now we differentiate A prime. So to differentiate A prime, all right, so let's say A equal to XY. So we note that this is U and this is actually V. All right, so to do that, so you have to do like kind of, all right, so U equal to X, V will be equal to Y. Differentiating X will give you 1, but differentiating V will give you, okay, differentiate Y, we get 1, but because it is Y, not X, so you have to write dy over dx. Right, so you have to use the product rules where uv prime plus vu prime. So your final answer will be, all right, so you have to cross multiply x dy over dx plus 1 multiplied by y, you get y. All right, that one is for A. So let's look at B, where B is given by 3x squared. All right, so for B prime there is no problem, I guess. You get 6x, and then you have C. All right, so let's say we have C here, where C is given by 2 cos of x plus y. So to differentiate this, all right, so let's do this. C prime will be, all right, so firstly we have to differentiate cos. Differentiating cos will give you -2 sine, all right, sine of what? Sine of x plus y. But we still have this x plus y to be differentiated. So differentiating x plus y will give you, differentiating x will give you 1, plus differentiating y will give you 1, but it is y, not x, so it is dy over dx. Okay, so we can actually expand this one. All right, so you can expand this. All right, so you'll get -2 sine of x plus y. And then you expand this one, you'll get -2 sine of x plus y dy over dx. All right, so that one is for C prime. So now let's look at D prime. All right, sorry, D. All right, so well, D is given by e to the power of 3y. All right, so differentiating this will give you, all right, first differentiating exponential will give you the same function, but now you have to differentiate the indices, where in this case the indices will be given by 3, but because it is y not x, so it should be dy over dx. Right, so you can write this as 3e to the power of 3y dy over dx. Okay, so you have differentiated everything here. So we note that if we differentiate that, we'll get, all right, kind of a prime, a plus b. So plus b prime will be equal to, right, c minus d. So it will be c prime minus d prime. So we're going to plug in into the formula. So a prime, which is given by this. So we have, okay, x dy over dx plus y. All right, that one is for a prime. Now I'm going to write b prime, which is given by this. You have to plus 6x, which is equal to, right now we have c, which is given by this. So we'll have negative 2 sine of x plus y minus 2 sine of x plus y dy over dx. All right, and we have minus d prime, so we have to minus this term. All right, so we'll have 3e to the power of 3y dy over dx. So basically that's it for, all right, so we have already written this one, and then we have to find dy over dx. So the tips for this is that if you reach to this level, you collect all those terms with dy over dx to the left side. So those having dy over dx you bring to the left, but those without dy over dx you bring to the right. All right, so in this case, right, I'm gonna write x dy over dx, and then I bring this part. All right, I will become plus 2 sine of x plus y dy over dx, and then I'm writing this one, it will become plus because we bring to the left side. So 3e to the power of 3y dy over dx. All right, now we're going to equal to, right, I'm writing this one first, negative 2 sine of x plus y, and then I'm writing this one, it will become minus y, and then you subtract this 6x. All right, so we note that we have this dy over dx for 3 terms at the left side. So we can factorize that dy over dx. So we factorize, we'll get something like this. So leaving only x plus 2 sine of x plus y plus 3e to the power of 3y inside the bracket. All right, so the left side still have that negative 2 sine of x plus y minus 6x. So I'm gonna bring this whole thing to the right side by dividing it, so that we can have the dy over dx at the left hand side. So dy over dx is left alone. So we'll have negative 2 sine of x plus y minus y minus 6x. So we bring everything in this bracket to the denominator. So we'll have something like this one divides x plus 2 sine of x plus y plus 3e to the power of 3y. So we are done with the first question. So that's basically how to solve the implicit differentiation. So firstly, you're going to divide this into a, b, c, and d if you have 5, and then you have e. All right, now you're going to differentiate each term here. All right, so we'll have a prime, b prime, c prime, and d prime, and then plug it into the formula. And then you try to bring everything, every term with the dy over dx you bring to the left side, and then those without the dy over dx to the right side. And finally, you factorize and you bring those terms that have been factorized to the denominator. So you get a final answer for dy over dx. All right, so let's now move to question number 2. All right, so we're going to write this as a, and this one as b, and the last one as c. So I'm going to write a is equal to y square. So differentiating this will give you, all right, 2y. But is it x? No, it is y. So we have to write dy over dx. All right. So now we have b. So b is actually sine of 3 to the power of, sine to the power of 3 of 2x. So we put this into the bracket like this. All right. So we have to differentiate this. So b prime will be 3, all right, sine of 2x, 3 minus 1 will be 2, and then differentiating the one inside the bracket will become cos of 2x, and then differentiating 2x will give you 2. So we can simplify this one, so it become 6 cos 2x sine square of 2x. All right, so that one is b prime. So we have c. Another one, we have c. So maybe I write here. So c will become tangent of xy. All right. So I'm going to differentiate this. So c prime will become, all right, differentiating tangent will become secant square of what? Of this xy. But now we have to differentiate this xy. So differentiating that xy, we'll have to use the product rule, where you have the u is equal to x and v is equal to y. So u prime will become 1, but v prime will become 1, but it is y, so 1 dy over dx. So we have to do the cross multiply here. All right, so x dy over dx plus multiply these two plus y. All right, so now I'm gonna expand this one first. All right, so it will become x secant square xy dy over dx plus y secant square of xy. If you have no idea what I've been doing, so it's something like I expand these two terms here, right? All right, so now we have a prime, b prime, and c prime. So we know that the answer should be in form of like kind of a prime will be equal to b prime plus c prime. We're following this, all right? A prime, which is equal to b prime plus c prime. All right, so now we're gonna put into the formula. So a prime is given by this, so 2y dy over dx is given by, all right, b prime is 6 cos 2x, 6 cos of 2x sine square of 2x, right? And then we have plus, right, those c prime is given by this, so we'll have something like x secant square of xy dy over dx plus y secant square of xy. All right, so now we have two terms with dy over dx. So remember, when we have to reach this level, we have to bring all those terms with the dy over dx to the left side. So we'll have something like, all right, so 2y, and I'm going to bring this term into the left side. So minus x secant square of xy. I'm sorry, so that one is 2y dy over dx, all right? So 2y dy over dx. So this one also dy over dx. All right, so I'm left with the 6 cos of 2x sine square of 2x plus with the y secant square of xy at the right side. Right now we have two terms with dy over dx, so we have to differentiate this. So differentiating this, factorizing this, it will give you kind of 2y minus x secant square of xy dy over dx. We already factorized the dy over dx here. So 6 cos of 2x sine square of 2x plus y secant square of xy. So the last step we have to do is to bring all these terms to the right side by the operation of division. So we'll have something like dy over dx. So we have to bring this to this side by dividing it. So this one is copied, right? So 2x sine square of 2x plus y secant square of xy. So you divide everything here with the 2y minus x secant square of xy. So that is your final answer. But don't make mistakes like, okay, I see secant square of xy here. All right, then you want to cancel. I want to cancel. No, you can't do that because you have operation here, right? So you cannot cancel that. Okay, so that's it. All right, let's move to question number 3. All right, where is question number 3? All right, so suppose this is A and this is B and we let this is C. So A A will be, all right, I'm writing A first, so 3 sine of xy. So differentiating this will give you, all right, so firstly differentiating sine will give you cos, 3 cos of what? Cos of xy. And then differentiating the xy, all right, the one inside the bracket will give you, all right, so again we have to do this u equal to x and v equal to y. So u prime will give you 1 and v prime will give you, differentiating y will give 1 what? 1 dy dx. So you will have something like this one, all right, x dy over dx plus this one multiplied together, you get y multiplied by 1, all right. So now I'm going to expand this one, all right, so expand this inside here. So I'll have something like 3x cos of xy dy over dx plus 3y cos xy. Okay, so I'm done with differentiating A. So now I'm going to differentiate B. So I'm writing B first. So B will become e to the power of 2x plus y. So B prime should be, all right, so differentiating exponential is you get the same function, 2x plus y, but now you have to differentiate the indices. So differentiating 2x will give you 2, differentiating y, all right, differentiating 2x done, you're going to differentiate y now. Differentiating y will give you 1 dy over dx. So I'm going to expand this one. So I'm bring this multiply together. So this will give you 2e to the power of 2x plus y plus e to the power of 2x plus y dy over dx. All right, so we already have B. Now we have C to be differentiated. So we have C, which is given by the function x squared. So differentiating C will give you 2x. Easy. Do we have dy over dx here? No, we don't have that. Because of what? Because this is x, not y, right? If it is y squared, then we have 2y dy over dx. So now we're going to write a prime minus b prime equal to c prime. So first writing that, a prime minus b prime equal to c prime. So put into this equation. So we'll have something like 3x cos xy dy over dx plus 3y cos of xy. All right, that one is a prime, so we're going to minus b prime. Bear in mind that we have to minus the whole thing here, so please put that in the bracket. All right, so we'll have 2e to the power of 2x plus y plus, all right, e to the power of 2x plus y dy over dx. And this is equal to c prime, which is given by this, which is 2x. Right, so firstly, I'm going to expand this one, that negative symbol first. So we'll have something like 3x cos of xy dy over dx plus 3y cos of xy. We have to minus the 2e to the power of 2x plus y, and then minus e to the power of 2x plus y dy over dx. And we have 2x to the right side. So we have to bring those terms without the dy over dx to the right side, meaning to say that the highlighted with yellow color should be brought to the right side. Right, so I'm going to write 3x cos of xy dy over dx minus e to the power of 2x plus y dy over dx. So writing this one first, so we'll have 2x and then we minus the 3y cos of xy, and then we have to plus 2e to the power of 2x plus y, because we already bring these two terms to the right side. Okay, so now we're gonna factorize this dy over dx. So we'll have something like 3x cos of xy minus e to the power of 2x plus y. So the dy over dx is outside the bracket here. All right, so we'll have 2x minus 3y cos of xy plus 2e to the power of 2x plus y. Right, so next step is that you have to bring all these terms to the right side by the process of division, and then you got the dy over dx. So your dy over dx will simply be, all right, so writing this one first, cos of xy plus 2e to the power of 2x plus y. You divide everything with these terms, all right? So that is 3x cos of xy minus e to the power of 2x plus y. Right, don't simply cancel this with this and this with this. Please don't do that, because you have the operation there, which is the addition and subtraction. All right, so you just leave your answer like this. Okay, so that's for the 3 examples of implicit differentiation. Right, let's now move to the question number 4. All right, so let's try the question number 4, which is given by this. Okay, so I'm assuming this as A, this one as B, and this one as C. All right, so we need that for A. All right, so let's say, okay, what do we call that? A is actually 3 of y over x, something like this. So to solve this, we have to use, all right, instead of using u over v, I'm making it as uv prime, sorry, the uv product rule. So this will become 3yx to the power of -1, so that I can use u as y and v as x to the power of -1. When I'm differentiating this, u prime will become dy over dx, and v prime will give you -1x to the power of, or I'm not writing 1 there, so -x to the power of -2, which is the same as a -1 over x square. Okay, so this is actually 1 over x. So now I'm multiplying these two terms, all right. So for a prime, it will give you, all right, so we know that it is uv prime, so plus vu prime, so we have to multiply these two terms. So I will get y multiplied by -1 over x squared plus the 1 over x, the dy over dx. So simplifying this first, so I'll get something like -y over x squared plus 1 over x dy over dx. Right, that one is for a prime. So now I'll go to b. So for b, all right, so b is given by 7e to the power of x ln, I'm sorry, because we have the 3, all right, be careful here, we have the 3 as the coefficient here, so don't forget the 3 there. All right, so expanding that will give you -3y plus 3. All right, I'm sorry, so be careful when differentiating this. The same goes to this. All right, so if you, all right, now this one I'm putting the coefficient aside, but this one I'm going to combine together inside a differentiation, because both of these uses the product rule. All right, let's see, ln of sine y. So let's say this is u, all right, and this is v. So I'm writing that u is equal to 7e to the power of x. Now I'm assuming that 7 is inside u, but in this case I don't put this 3 inside u, right? So look at the difference, just the same actually. So v is equal to ln of sine y. All right, so u prime will give you 7e to the power of x, and v prime will give you 1 over sine of y, but sine of y need to be differentiated. Differentiating sine will give you cos of y, and now we have to differentiate what we call that as y. So we'll have to differentiate y, will give you dy over dx. All right, so now to write that b, so we'll have b is given by, all right, uv prime. So uv prime will give this. So please note that this is actually, all right, cos y over sin y will give you, all right, cos y. I'm writing cos y over sin y first, dy over dx. So this is actually cos y over sin y is actually cotangent y, dy over dx. Okay, all right, so b prime should be, I'm multiplying these two terms, So 7e to the power of x cotangent of y dy over dx plus, now I'm multiplying these two together, so I'll get 7e to the power of x ln of sine y. Alright, so that one is for b prime. So now we're going to move to c. So suppose c is actually given by the function 4x squared. So c is given by 4x squared, so c prime will give you 8x. Alright, so we have a prime plus b prime will equal to c prime in this case. So right first, a prime plus b prime will give you c prime. So putting the a prime first, alright, so we're going to insert this, what do we call this term? Alright, so we'll have negative 3y over x squared plus 3 over x dy over dx. Now we're going to plus with the b prime, should give you this part here. Alright, I'm sorry, the whole thing here. So we'll get 7e to the power of x cotangent of y dy over dx plus 7e to the power of x ln of sine y. And then this will equal to c prime is given by this, so 8x. Alright, so in the implicit differentiation, if possible, you can avoid the fraction, where in this case we have fraction here, right? So to remove that fraction, so we'll have to multiply each term with what we call x squared. So multiply this term with x squared, multiply this term with x squared, you also multiply this with x squared, multiply this with x squared, and also multiply this with x squared. Right, look at what happened now. If we multiply this with x squared, so we are left with negative 3y. Now multiply this with x squared, now we'll have something like 3x, plus 3x dy over dx. Right, now we don't have any fraction. Plus, alright, multiplying this term with the x squared will give you 7x squared e to the power of x cotangent of y dy over dx. Alright, so now we'll multiply this with the x squared. We'll have plus 7x squared e to the power of x ln of sine y. And multiplying this term with x squared will give us 8x to the power of 3. So now we want those terms with the dy over dx at the left side, and those without the term dy over dx, we have to move to the right side, meaning to say that we have to bring this to the right side. So we'll have something like, and also this one to the right side. Okay, so we are left with 3x dy over dx plus 7x squared e to the power of x cotangent y dy over dx. So we'll have, write this one first. So 8x to the power of 3, we have to plus, I'm bringing this one first, plus 3y, and then we have to minus the 7x squared e to the power of x ln of sine y. Okay, so to be confident about what you have done is right, so you have to calculate this one. We have 1, 2 terms, 3 terms, and 4 terms, and 5 terms, and you should have 5 terms here. 1, 2, 3, 4, 5. All right, so now we have to what do we call that, factorize the dy over dx. So factorizing dy over dx will give us 7x squared plus ex cotangent of y of dy over dx outside the bracket, right? Something like this. So we'll have 8x to the power of 3 plus 3y minus 7x squared e to the power of x ln of sine y. So the final step is that we have to bring those terms inside the bracket to the right side, so that we're left with the dy over dx alone at the left side. So we'll have dy over dx. So write everything here first. So we'll have something like 8x to the power of 3 plus 3y minus 7x squared e to the power of x ln of sine y. So everything over the 3x plus 7x squared e to the power of x cotangent of y. So that's your final answer for this one, right? Whew. Very, very challenging. Let's do the last question for the implicit differentiation here. So in this case, all right, I'm writing this as A and this part as B and this part as C. Right, so we'll have something like, okay, A is given by ln of sine y squared. So differentiating A will give us, all right, so differentiating firstly, you have to differentiate ln. Differentiating ln will give me 1 over sine of y squared, and then we have to differentiate the sine. So differentiating sine will give me the cos. So cos of what? Cos of this y squared. And finally we have to differentiate the y squared here. So in this case the y squared will become 2y, but because it is not x, so it will become 2y dy over dx. All right, so that one is for A. So I can write this as, alright, cos of y squared over sine of y squared, 2y dy over dx. So I'm writing 2y in front, so 2y. So please note that this part will become cotangent. Cotangent of what? Cotangent of y squared of dy over dx. We'll simplify this one. Right, that one is for A. Now I'm writing for B. So B is given by x over y. So this can be used as, alright, so let's say I want to use the u over v. So u is equal to x and v is equal to y. So u prime will give you 1 and v prime will give you dy over dx. So to use the formula, so remember the formula for the quotient rule, the u over v. So vu prime, so we have to multiply these two first. So vu prime will give us y minus the uv prime minus these two terms, all right? So minus x dy over dx divided by v squared. So this one v squared, so y squared. So that one is for b prime. So we can also simplify this as, all right, so y over y prime minus x over y, sorry, y over y squared minus x over y squared dy over dx. All right, we may also write it like this because later we want to remove that y square. Never mind, we just write it like that. All right, b prime is like this. All right, and the last one we have c then. All right, so c will become e to the power of 3y. All right, so to differentiate this, so c prime will give us, all right, so firstly differentiating the exponential, we get the same function, and now we have to differentiate the 3y there, so we'll have 3 dy over dx. Why dy over dx? Because this is y, not x. All right, so we can write this c prime as 3e to the power of 3y dy over dx. All right, so we have a prime, b prime, and c prime. So we know that the given function is actually a minus b equal to c. So the a prime minus b prime equal to c prime. So we have a prime minus b prime all equal to c prime. So a prime, so given by this, so 2y cotangent of y squared dy over dx. We have to subtract the b prime. So we have to subtract everything here. So subtracting that, all right, I'm writing it in the bracket, y minus x dy over dx over y squared, and then we have equation, all right, so this is equal to 3e to the power of 3y dy over dx. So how do I remove this, what do we call that, the denominator there? We don't want fraction, so I have to multiply this here. Okay, so I've got something like, all right, the first term is multiplied by y, so this one will become 2y to the power of 3 cotangent of y squared dy over dx. And then we have minus, all right, minus the everything in the bracket, minus y minus x over dy over dx. And multiplying that y squared to the right side, we'll get something like 3y squared e to the power of 3y dy over dx. Okay, so now I'm going to expand this negative into the bracket. So I'll have something like 2y to the power of 3 cotangent of y squared dy over dx minus y plus x dy over dx. This is equal to 3y squared e to the power of 3y dy over dx. Alright, so remember, for implicit differentiation, those terms with dy over dx should be brought to the left side, and those without the dy over dx should be brought to the right side. So at the left side is left with the 2y to the power of 3 cotangent of y squared dy over dx. So we'll have this plus x dy over dx, and we have to bring this function to the left side. So we'll have minus 3y squared e to the power of 3y dy over dx. So for this term, we have to bring it to the right side. We'll get positive y. Okay, so now we have three terms with the dy over dx. We have to factorize it. So this will become, all right, put it in the bracket. So 2y to the power of 3 cotangent of y squared plus x minus 3y squared e to the power of 3y. So that dy over dx is put outside the bracket here. This is equal to y. So now the last step, you have to bring all these terms to the right side by the process of division. So we will have, right, so dy over dx is equal to, all right, I'm writing y at the numerator. So everything, this one is over 2y to the power of 3 cotangent of y squared plus x minus 3y squared e to the power of 3y. So that's it. That's your final answer. All right, so yes, I know for implicit differentiation, it's quite complicated. Not that complicated. It's the working is quite tedious. All right, so you just have to do a lot of exercises. Inshallah, you can do. But be careful when dealing with the differentiation, because you may get confused when it comes to the product rule, which is the UV, right? Like for this part, most of the students make mistakes because they don't see this as U multiplied by V. All right, so that's it. Thank you for watching.